Hello amazing learner, welcome back to the Zoom Chemistry Hub. In today's session we are going to dive into a important concept from the chapter solutions, that is the ideal and non-ideal solutions. So let's begin by understanding what these solutions are. So let's start with ideal solution. We can define the ideal solution as an ideal solution is a solution that obeys Raoult's law at all concentration and temperature. Raoult's law statement for ideal solution is that the pressure of a component A is equal to the mole fraction of A and the vapor pressure of the pure component or the vapor pressure of A before the mixing in the solution, and the vapor pressure of B is equal to the mole fraction of B into the vapor pressure of the pure component, that is B, before the mixing. So the total pressure after the mixing is equal to the mole fractions of A into the vapor pressure of A in the solution plus mole fractions of B into the vapor pressure of B in the solution. Now key features of ideal solutions. First feature, that is del H, or no enthalpy change on mixing. So del H is equal to 0. It means that there is no heat loss or gain of heat in the ideal solutions. So here the del H or enthalpy is 0. Next features for ideal solution, that is no volume change on mixing. When we mix the component and make the ideal solution, then there is no change in volume before the mixing and after the mixing according to the Raoult's ideal solution, that is del V is equal to 0. Similarly, third point is similar intermolecular forces. These forces between the component AA and the component BB and the component A and B are almost all the same. So before the mixing and after the mixing, the force between these components of the same or with different component all are same. Examples of ideal solution: benzene and toluene. Similarly, hexane and heptane and ethyl bromide and ethyl iodide are the examples of ideal solutions. These solutions behave ideally because their molecular size and interaction are very similar to each other. Next, non-ideal solutions. So we can define the non-ideal solution as a solution that does not obey the Raoult's law over the entire composition range. So the solution which does not or which do not obey the Raoult's law, this solution is called non-ideal solution. Key characteristics. First, the enthalpy. Del H is not equal to 0. So there is either absorption or evolution of heat during the mixing of the component A and B. So del H is not equal to 0. Next point, change in volume, that is del V is not equal to 0 in the non-ideal solution. So the volume may expand or contract on mixing of the component A and B. Similarly, the third features of the non-ideal solution is different intermolecular forces. So the AB interaction is either stronger or weaker than the interaction of AA and BB. So the interaction of AB, both of the two solution in the after the mixing, is either stronger or weaker than the interaction before the mixing of AA component and BB component. Now the types of non-ideal behavior. So we have two types of non-ideal behavior. First, the positive deviations from Raoult's law, and second, the negative deviation from Raoult's law. First, we will discuss the positive deviation from Raoult's law of the non-ideal solutions. The interaction or AB interaction are weaker than AA component and BB component, and the more molecule escape leads to the higher vapor pressures. And in this positive deviation, the heat is absorbed, so the change in enthalpy is greater than 0. Examples for the positive deviations are the ethanol and acetone, similarly carbon tetrachloride and toluene. Both behave the positive deviation from the Raoult's law. Next types of non-ideal behavior, that is the negative deviation from Raoult's law. In the negative deviations, the interaction of AB are stronger than the interaction of AA or BB. So the fewer molecules escape from the surface of the solutions and leads to the lower vapor pressures. So the vapor pressure will be low, and in this case the heat is released, so it is an exothermic process, and in this, during this release of energy, the change in enthalpy is less than 0. Examples are the chloroform and acetone, and similarly nitric acid and water. So let's quickly compare ideal and non-ideal solutions. Ideal solution obey the Raoult's law, while the non-ideal solution do not obey the Raoult's law. Similarly, del H or change in enthalpy is 0 in ideal solution, while it is not equal to 0 in non-ideal solution. Similarly, change in volume in ideal solution are 0, while in non-ideal solution the change in volume is not equal to 0. Similarly, the interactions in ideal solution, the interactions of component AA may be equal to the component BB, and this interaction are equal to or may be equal to the interactions of A and B. Similarly, in the non-ideal solution, the interactions of component AB is not equal to the interaction of AA or interactions of BB. Examples of ideal solutions are benzene and toluene, and the examples of non-ideal solution is the chloroform and acetone. Summary: ideal solution obey Raoult's law with no enthalpy or volume change, and non-ideal solution show positive or negative deviations due to the unequal molecular force. That's all for today lectures on ideal and non-ideal solutions. Please like, subscribe and share this video. Thanks for watching.